Okay, now we will introduce our very last exponent rule. I want to reiterate this. I know this 2 to the third over 2 to the third is an overlap, but it just ties things together. So the first part of lecture 19, the video, we saw that 2 to the third over 2 to the third was 8 over 8, which is 1. But if we use our rules, they have a common base, so we subtract their exponents, and we get 2 to the 0. So it's just an illustration. It's not a proof, but it just hopefully helps it makes a little more sense that anything to the 0 power is 1. Now let's keep continuing the pattern of what we were doing. If we have 2 to the third over 2 to the fourth, well, that's 8 over 16, which is 1/2. Okay, if we use our rules, we have a common base, so we subtract the exponents. That's 2 to the 3 minus 4, or 2 to the negative 1. Just hold on to that one for a second. Let's keep going with the last one. 2 to the third over 2 to the fifth is 8 over 32, which is 1/4. And 1/4 is the most simple form of that answer, but there's a very specific reason why I want to write it slightly differently. I want to write 4 as 2 squared, and it really is the same. I know that it might not seem, might not see why, but just bear with me for a minute. Okay, let's go the other direction, and actually let's just look at that and see if it makes sense. I have 3 2's on the top, 5 2's on the bottom, so that makes sense that I have 2 more 2's on the bottom. So I'm going to have 2 2's on the bottom and no 2's left on the top. Okay, let's go the other direction with our rules. 2 to the 3 minus 5 is 2 to the negative 2. So you see if we have 2 to the negative 1, it's 1 over 2. If I have 2 to the negative 2, it's 1 over 2 squared. So my rules are if I have a to the negative n, it's 1 over a to the n. That's what I've just kind of illustrated a little bit. Now, it follows that if I have 1 over a to the minus n, if I have an a to a negative exponent in the bottom, in the denominator, that can become an a to the positive n by moving up. So if you see a negative exponent, that means that it wants to move whatever it has power over. Either if it's in the numerator, it wants to move to the denominator. If it's in the denominator, it wants to move to the numerator. So let's look at some examples right here. You'll notice with these examples that we can do things in multiple ways. And there's not a right way and a wrong way. As long as you're using the rules correctly, you're going to be fine. So let's take negative 4 times b to the third to the negative 2. Now, I could go different directions with this, but I've decided that I want to use rule number 3 first. So look at rule number 3. We've got all of our exponent rules over here on the left. Rule number 3 tells me that if I have rule number 4, if I have, actually I guess I'll use 3 and 4. If I have two things inside parentheses, I can give the exponent to both of them. So that'd be negative 4 to the negative 2 and b to the third to the negative 2. Now remember what a negative exponent means. It says that if it's in the numerator, it wants to move to the denominator. Well, I don't have a numerator or denominator, so I think of it as being over 1. So when I move it, it leaves 1 behind, so I have 1 over negative 4 squared, b to the third squared. When they move, the sign comes off of the exponent. It's almost like you've already used that ticket. You have to give the ticket up to the conductor. He's already made the trip down, so he's got to get rid of the negative. Now notice that negative 4 does not move anything. That negative 4 is just a sign on a number. It's not a negative on an exponent. So we'd have negative 4 squared is 16. b to the third squared is b to the sixth. Then I'd be done. Now look at this next one. It's a little similar, but not, there's obviously a difference. What's the difference? Okay, the difference is that the negative 4 is outside of the parentheses. What practical difference does that make? Good. That means that negative 2, the exponent of negative 2, it no longer has any power at all over the negative 4. The only thing that it's going to move is the b term. It will not move the negative 4. Negative 4 stays, and the b cubed squared goes to the bottom. Now that negative 4, the negative on the negative 4 doesn't move it. That's just a negative number. It's not a negative exponent. My b cubed squared is just b to the sixth. So those are our first examples. Let's do a few more. Okay, I have w to the 7th over w to the negative 2. I want to do this either using rule 2 or rule 7. Again, there's just a lot of different ways to do these, so I'm going to do this problem 2 different ways. Pause it actually and see if you can do these on your own. All right, so with rule 2, that says if I have common bases, I subtract the exponents. Be very careful with your signs. Notice that it's 7 minus a negative 2, not just 7 minus 2. It's an easy mistake to make, and a lot of people make it. You've just got to be careful. That would be 7 plus 2, which is w to the 9th. So that's if I use rule 2. Look at rule 2. That says if I have common bases, I subtract the exponents. Now, what does rule 7 do? Rule 7 moves things around. If they have a negative exponent, it moves it from the top to the bottom or the bottom to the top. So I have a negative exponent. I have w to the negative 2. The only thing it has power over is that w in the bottom. So that could move that w to the negative 2 to the top. And now I have w to the 7th times w squared, which gives me w to the 9th. No matter which way I do it, no matter which rule I use, as long as I use the rules correctly, then I will get exactly the same answer. Now, if you were tempted to say w to the 5th on the first one, look at this guy. That guy gives you 7 minus 2, or w to the 5th. Look at the difference between them. In the first one, you're subtracting a negative. Make sure you've got that double negative in there. Okay, next examples. 5 times x to the minus 3. This is very short, and it's a pretty easy example. And I want you to write down what you think the answer is on your own. But I also want you to write down what you think the most common wrong answer is. Okay, so what does that negative 3 have power over? It only has power over the x. The x is the only thing that moves. 5 stays on the top. Your x to the 3rd goes to the bottom. You always want to rewrite things without using any negative exponents. Okay, now I've also got a new rule. If you look at rule number 2, I've put a little extension on there. This extension is very useful if you happen to have more of a variable on the bottom than you do on the top. You can still do it the standard way. It will absolutely work, and that's what we're going to do on this next example. We'll do the next example using just plain old original rule 2, and then we'll use it using our new improved rule 2. So with plain old original rule 2, I have common bases of a's, so I have 3 minus 8 would be the exponent for a, 7 minus 3 would be my exponent for b, and 2 minus 1 would be my exponent for c. Absolutely nothing wrong with doing it this way. It will work just fine. So now let's simplify. 3 minus 8 is negative 5. 7 minus 3 is 4, and 2 minus 1 is 1. So that would give me a to the negative 5th, b to the 4th, c. Okay, still fine, but I can't leave my answer in that form because I can't write my answer with negative exponents. So that a to the negative 5, the negative 5 only has power over the a, so the a is the only one that moves. And when it moves, it uses up its negative sign. So it becomes an a to the 5th. Nothing wrong with doing it that way. But if we look at this problem, look at the original problem again. The a to the 3rd, b to the 7th, c squared over a to the 8th, b to the 3rd, c. Let's look at the c's. Who has more c's, the top or the bottom? Well, the top, so I know the c's are going to end up on the top. Look at the b's. Who has more b's, the top or the bottom? The top, so I know that the extra b's will be on the top. Who has more a's, the top or the bottom? The bottom has more a's, so all the extra a's will be on the bottom. So if I use my modified rule 2, for the b and the c, I do exactly the same thing that I did before. 7 minus 3 for the b exponent and 2 minus 1 for the c exponent. But I could say, well, the a's are going to be on the bottom, so it's 8 minus 3 on the bottom for the a's. That kind of, since I know my a's will end up on the bottom, I can just kind of keep them down there. So it just gives me b to the 4th c over a to the 5th in one less step. It's not a big difference, and it really doesn't matter which way you do it. I just want it to make sense both ways.